Second lesson for algebraic expressions we'll cover today, and it can be found in your M3-T1 expressions tab, and we're looking for 1.2 Introduction to Algebraic Expressions. If you're in the workbook, you want to begin on M3-23. Into the unknown. All right, Introduction to Algebraic Expressions. We're going to skip through some of this here. The getting started, I want you to think about this really quickly. I'm not going to go over these, but go ahead and pause the video here for a second and see if you can rewrite each statement using math symbols. So one example would be 14 more than 6. You would write 6 plus 14. This kind of gives you a little hint into what we're doing today with this lesson. So just test out your skills. Would you be able to do that for all of these, 1 through 11? All right, then let's go ahead and skip to activity 2.1, writing expressions with variables. Consider the quantity that changes as you think about the situations in question 1. A school lunch costs, hold on just 1 second, please. Okay, a school lunch costs $1.85 for each student. For each situation, write a numeric expression to determine how much money is collected, then evaluate the expression. All right, so it says 55 students purchase a school lunch. So if I'm going to write a numeric expression, I would do 55 times $1.85. And then evaluate it means answer it. So 55 times $1.85, I can use my calculator. I should get $101.75. Go ahead and pause this and figure out B, C, and D, and then come back in and check with me. Okay, as you come back, if you did B, 126 student lunches, you would have gotten 126 times $1.85 is $233.10. 213 students times $1.85, $394.05, and 1,512 students times $1.85 is $2,797.20. It says, write a sentence to describe how you can determine the amount of money collected for any number of students buying school lunches. Well, how could I determine it? All I have to do is multiply the number of students buying school lunches by the cost. Oops, the cost. And in this case, it would be $1.85. Every single time that's going to work for me if I know how many students are having lunch. In question 1, there is one quantity that changes or varies the number of students who bought school lunches. In mathematics, letters are often used to represent quantities that vary. These letters are called variables, and they help you to write algebraic expressions to represent situations. An algebraic expression is an expression that has one variable. So write an algebraic expression to represent the total amount of money collected for any number of students buying school lunches. What's the thing that changes all the time? The number of students, and so the number of students is our variable, and we're going to represent that with an S. So to write my algebraic expression, if I know how many students are having lunch, all I have to do is take that times $1.85. This is what we call an algebraic expression. When you have a number that's multiplied to a variable, there's a special name for this number, and they call that a coefficient. So any number multiplied to a variable is called the coefficient. All right, let's keep going. We just answered. It said a number that's multiplied by a variable is in fact called a coefficient, and we just did that for number 4. Number 5, it says, on a side note, if a coefficient is not shown, it's understood to be 1. So the coefficient of a plain old x is 1. Good to know. Number 5, the cost to rent a skating rink is $215 for a 2-hour party. The cost will be shared equally among all the people who attend the party. For each number of attendees, write a numeric expression to determine how much each person will pay and then evaluate it. Okay, well, it's $215 divided by 25 attendees. Well, that's going to end up being $8.60 a piece. I could also write it as 215 divided by 25, but you're going to notice a lot of times in our book they're going to want us to do it as a fraction. Either way works. Go ahead and try to figure out what it is for 81 attendees and 108 attendees. Okay, so for 81 attendees, I would do 81 divided by, oops, that's wrong. Just playing catch my mistake here. I would do a 215 because that's what it costs, divided by 81 attendees would end up being $2.66 a person. And if I had 108 attendees, that would be 215 divided by 108 attendees, and that would equal $2 a person. All right, so it says write an algebraic expression to represent how much each person will pay to attend the skate party. So in every case, I knew the number. I knew it was 25, 81, 108. What if I didn't know what it was? That's where my algebraic expression comes in. So I can write it like this. 215, I got the disappearing ink going on again. 215 divided by, what do I want to say? Persons. So I'm going to use a P for person attending the party. That'll be my variable. Okay. Number 6, Jimmy has a 300-minute international calling card. Complete the table to determine how many minutes are left on each card after the call. So if he has 300 minutes on the card and he talks for 33 minutes, we're going to have to subtract, and he's going to be left with 267 minutes. I can use my calculator on this. Go ahead and figure out the other two. All right, so hopefully you got the answers that I got, 243 minutes, 223 minutes. Write an algebraic expression that represents the number of minutes remaining on the card. So what was the variable? What was the thing that changed every time? It was this right here. So our algebraic expression could be 300 minus, let's call them M, and M will stand for minutes. And that will be able to tell us how many minutes are left on the card. Good. Algebraic expressions usually don't have equal signs, so we can leave it just like that. Let's keep going. Number 7, write an algebraic expression to represent each situation and identify the coefficients. Go back here a second. The coefficient on this guy would just be plain old 1, because remember, if there isn't one there, it's understood to be 1. So Ben is selling tickets to the school play. How many will he have left if he starts with T tickets and sells 125? He starts with T tickets, and he ends up, how many will he have left? He starts with, and he sells 125. And so that's what our algebraic expression looks like. And then it also tells us to identify the coefficient. So the coefficient in this case, I'm having the disappearing ink problem. the coefficient would be 1. Okay. Let's see, a plane, we'll try drawing with my finger, maybe that will work better. A plane descends to 5/6 of its cruising altitude, A. What's its new altitude? All right, I see the word of. When I see the word of, that means multiply. So I know it's going to be 5/6 times A. That's my algebraic expression. What's the coefficient? This is going to be the coefficient. Sorry, my handwriting's really bad when I have to write with my finger, because that's what's being multiplied by A. All right, how about on C? It says a cube has an edge length of S. What's the volume and what's the surface area? And I have to write an algebraic expression. Well, I know volume is length times width times height. And I know in volume with a cube, they're all three the same. So if the edge length is S, it's like saying S times S times S, or S cubed is a more shortcut way of saying it. The surface area, I remember that a cube has 6 sides. I'm going to need to know that. And the surface area is like finding the length or the area of each side. Well, to find the area of one side, that's a square. And I know it's a perfect square. And I know it's S. So to find the area of a square, that's like squaring it. S squared. And then there's 6 sides, so I'm going to times it by 6. That's how I would find the surface area of a cube. Moving on, a used paper book costs $6.25 each, with an additional shipping and handling cost of $8.75. What is the cost of X number of books? All right. Let's see. Think about this one for a second. And let's see. Additional costs, so that probably means that I'm adding. And then X books, so I must be doing some multiplying in there as well. So $6.25 times X plus the shipping and handling cost. Good. Chairs cost $35, sofas cost $75. How much does it cost to purchase X chairs, Y sofas? Well, chairs go with 35, so they go together, so it's $35 times X plus the Y and the sofas go together, so it's $75 times Y. That's the algebraic expression. Write an algebraic expression to represent each word expression. The quotient of a number n divided by 7. Quotient I know is the answer in a division problem, so it's n divided by 7, or I could say n divided by 7. 5 more than C. More than I know I'm adding, and it's 5 more than C. Go ahead, pause this, try the next ones on your own, C through H, and then come back. All right, on these, hopefully you got the following answers. 9 less than M, that means the M comes first. 1/4 of a number. Of always means multiply, so it's 1/4 times n. 14 less than 3 times a number n. I'm going to write them right next to each other like that. 6 times a number n, so 6n subtracted from 21. So that means subtracted from, that means 21 has to come first. 1/4 of, so 1/4 of a number n, that's 1/4 times the number n, minus 6, and 10 times the square of a number, w, so there's my number w, the square of it, divided by, use my fraction bar, divided by 12. All right, let's skip 2.2. We're going to do some of that in class together. So let's go to 2.3, our last section. Well, not of our last section. As you learned previously, an algebraic expression contains at least one variable, and sometimes numbers and operations. A term of an algebraic expression is a number, variable, or product of numbers and variables. Consider this expression. This expression has 3 terms, 3x, 4y, and 7. The operations in here are adding and subtracting, okay? The first term is, okay. So these first 2 terms are variable because they have a variable with them. The third term is a constant term because it's not going to change. It's always going to be minus 7. Consider 2 algebraic expressions, 8 plus 5x and 8 minus 5x. Which are the terms in this algebraic expression? 8 is and 5x. Okay, those are the terms. Identify the 2 operations between each term. Well, first one is add, and the second one is minus. What is the same in both expressions? Well, they both have the exact same terms. And what is different? Well, the operations are different in each one, because one's adding and one's subtracting. Identify the number of terms and then the terms themselves for each algebraic expression. Okay, identify how many terms. Well, there's 2 terms. I can see that. And then the terms themselves. So those are the 2 terms, and then the first term is a constant 4, and the second term is 3x. So they just want you to list it, 4 and 3x. In this one, we have 3 terms, 3 different things going on here, and they are a 4a, a constant, and another variable. And in the last one, we have 1, 2, 3, 4 terms, and that's a 7b, a 9x, a 3a, and a constant of 12. All right, moving on, we're going to evaluate them. We're going to actually attempt to kind of solve them, so to speak. To evaluate an algebraic expression, it means to determine the value of an expression for a given value of each variable. When you evaluate algebraic expressions, you substitute the given values for the variables and then determine the value of the expression. Write a sentence to describe the meaning of each algebraic expression, then evaluate it. Okay, so a meaning for it. So a meaning for this one, they're just saying, this is saying 3x minus 4. We're not going to actually write the meaning of it down. Let's go back. Try my stylus again, if it's on. Thank you for bearing with me. It is not wanting to work. Okay, we're going to go back to drawing with our finger, folks. Okay, to evaluate an algebraic expression means, okay, sorry, I'm getting off task. Okay, 3x minus 4, and x is 10. So that means we put a 10 in place of the x. So this is 3 times 10 minus 4. 3 times 10 is 30, and 30 minus 4 is 26. Okay, in B, if we put 2 in for s, we would get 11 minus 2, and that would equal 9. Go ahead and try the next 4 on your own. All right, on this one you can see we're going to put 8 in for z, so 10 minus 8, and then we're going to answer it. 10 minus 8 is 2. For this one, we're going to put 2 in for y, so this is saying 5 minus 2/4, which is a half. 5 minus 2 halves. I could change this to 4, 20 over 4. 20 over 4 minus 2 over 4 would be 18 over 4. 4 goes into 18. I'm really messing you guys up on that one. 4 goes into 18 4 times, and there'd be 2 left over, 2/4, which simplifies to 4 1/2. On E, you're going to put 20 in for A, so this is 7 plus 5 times 20. Well, 5 times 20 is 100, and 7 plus 100 is 700. And lastly, 8 in for B, 8 divided by 4 equals 2. Same thing can be done with tables. So when we have tables, we see what h, in this case, what h is going to equal, and we can substitute lots of different values for h into our equation. So let's do this first one together, and then I'm going to have you do the rest on your own. If we put h, 2 in for h, that would be like saying 3 times 2, and 3 times 2 is 6, and 6 minus 2 is 4. So 4 would be our missing number in that one. If we did 7/3 for h, that's like saying 3 times 7/3 minus 2. Well, I can simplify these, and I'm just left with 7 minus 2, and that equals 5. And if I do 5.1 in for h, that's, and I can use my calculator on these, I can take 5.1 times 3 and get 15.3 minus 2 is 13.3 as the missing value. And then finally 5/6 in for h, that's like saying 3 times 5/6. I can simplify, and that's 5/2. 5/2 minus 2 over 1. I could change 2 over 1 to be 4 over 2. And 5/2 minus 4/2 would be 1/2. All right. These might be a little challenging for you, but give them a try. Try B. Let's skip B. Let's try C and D, and go ahead and try those. All right, so for letter C, if we have evaluated them correctly, we put 1 in for Z. 1 times 2 is 2/3 plus 1 would in fact 1/3, 2/3. This is so hard when I can't draw with my stylus. 2 times 1 would be, it'd be 2/3 plus 1 whole would make it 1 and 2/3. And the second one would end up being 2 and 1/3. The next one would be 4 and 1/3. And the last one would be 8 and 1/3. Skipping over to letter D, if I put P, these values in for P, if I put 0 in for P, 0 times 0.5 is 0, because anything times 0 is. 0.5 times 1 is going to be that number, 0.5. I really apologize for my handwriting. If I do 0.5 times 1.5, I end up with 0.75. And if I do 0.5 times 2.5, I end up with 1.25. All right, we will stop there. We'll do some more practicing in class. Thanks.